team of doctors has just treated this woman's untreatable cancer using DNA editing. Let's talk about it. Your immune system needs to be very careful about what it attacks. If it starts going after your own healthy cells, things can go off the rails very quickly. So your immune cells have evolved all kinds of internal checkpoints they have to go through before they start kicking the wrong ass. One of those crucial checkpoint mechanisms is a protein called KISH, which is written into your cell's DNA. It's a voice of reason inside an immune cell that says, hey, don't punch that guy, he's on our team. But every cancer cell starts as a healthy cell, so they all look like an ass that shouldn't get kicked. That's one of the reasons that your immune system has such trouble fighting cancer, because they're bad guys that look like good guys. Usually, some immune cells will eventually detect the imposter. These are called tumor-infiltrating lymphocytes, or TILs. But just because a handful of TILs have successfully recognized and infiltrated enemy HQ, doesn't mean that they can defeat the tumor on their own. So what if you extracted some TILs from behind enemy lines, multiplied them, and then put them back into the patient with a few billion of their buddies? Well, this does work, but only sometimes. See, it doesn't matter how many TILs can recognize the tumor and get inside of it if that KISH protein is holding them back from killing it. So what if before you put the TILs back in, you edited their DNA to delete KISH entirely? You've essentially made a group of jacked up super soldiers that know the way to enemy HQ, and once they're inside, they can start banging heads together without anything holding them back. This idea saved Emma Dimery's life. By 2022, she had already gone through a decade of chemotherapy, radiotherapy, and immunotherapy, but her stage 4 colorectal cancer still hadn't been stopped. She thought she was out of options until she signed up for a clinical trial that would teach her TILs how to ignore it when cancer cells tried to fake their way out of getting whooped. The trial team harvested Emma's TILs and then used CRISPR-Cas9 DNA editing to delete the gene that serves as instructions for her cells to make the KISH protein. They then put 100 billion of those edited TILs back into Emma's body so that they could find the tumor and start kicking its ass. And it worked. Emma has been cancer-free for 2 years now. Now, Emma is only one of 12 patients on the trial who had their TILs extracted, edited, and put back in. The other patients didn't react quite as strongly for a variety of reasons that doctors are still trying to work out. But because this treatment works by taking the brakes off of the immune system, rather than depending on some feature of the cancer cells themselves, it could theoretically be useful for a lot more patients. Everybody's cancer is a little bit different, but everybody's KISH works the same. This is a huge step towards a treatment for cancer that is simultaneously tailored to the individual because it runs on your own homegrown cells, but also universally applicable because it runs on a mechanism that all of our bodies share.